Hello and welcome to another video, this time going through Mechanics Paper 2021 question 2, and it's a planes and forces question, or actually it's a pulleys question. So let's get on with it. Let's do the little prep work. Sine alpha is 3/5, cos alpha is 4/5. I like to do that straight away if they give me tan or sine or cos of the angle. How am I doing that? Just a little triangle with alpha in it. Opposite divided by adjacent is tan, so that's going to be 5, and therefore sine alpha is 3/5 because it's opposite divided by hypotenuse. Cos alpha is 4/5 because it's adjacent divided by hypotenuse. That's that done. Okay, let's start doing our diagram. We're going to have an mg going down here, t going up there, and we're going to have a 3mg down here. We have an alpha in it and an r going up like that. We're going to have a t pulling this one up here. Now we need to decide which way the friction goes. Well, we've got mg pulling in this direction and 3mg sine alpha pulling in that direction. 3/5 of 3 is 9/5 mg, and that's stronger than mg, so it's definitely moving in this direction. Yeah, and I think the question actually says that, because it says stone A is released and begins to move down the plane. Okay, so that means that friction should be running parallel to the tension up the plane, and it will be at maximum because it's moving. Okay, so what do they want us to do first? Write down an equation of motion for A. Well, if we do the stronger force, which is 3mg sine alpha, that's the stronger force going down the plane, minus t minus F max, that's going to equal to 3m A. Yeah? Now I don't need to put in sine alpha is 3/5 or work out F max because it's mu r or anything like that. Oh, note to self, I've got mu. They just want it unsimplified. But we're going to have to simplify in the next bit. Show that the acceleration of A is g/10. Now in these questions, you always do an equation of motion for A and an equation of motion for B. Now B's equation of motion is slightly easier. You just got t minus mg is ma. And if we add these two equations together, we will eliminate the t's and therefore be able to find the a's. So 3mg times by 3/5 is 9/5 mg. And then I'm adding this to this, minus t and t cancel. I've got minus an F max, which is a mu r, and then minus an mg, and that equals 4ma. Yeah? Now r, of course, in this question is going to be equal to 3mg cos alpha. And as cos alpha is 4/5, you're going to have 12/5 mg. And so what do we got here? We've got 9/5 mg minus mg, well that's 4/5 mg, minus a 6 times by 12/5 mg equals 4ma. The m's cancel, and we've got 4/5 minus, and that's going to be 2/5, which is 2/5 g equals 4a. Now just divide it by 4. I think if this is 4/10 divided by 4, you get g/10 is a as required. So these aren't too bad actually. They're big marks, but when you get used to doing pulleys questions, you realise it's big marks for not, for doing the same thing every time. Okay, sketch a velocity time graph for the motion of B from the instant when A is released to the instant just before B reaches the pulley. Explain your answer. So they want B going up. We want a velocity time graph for B. Okay, so if we're thinking about a velocity time graph for B, it's released from rest, so initial velocity is 0. And the other thing to note is it's under the action of a constant force, yeah? Namely, t minus mg. We could work out t, by the way, because A is g/10. So you've got gm/10 plus g/10. It's going to be like 1.1 mg t, yeah? And 1.1 mg minus mg is 0.1 mg up, if you see what I mean. So it's under the action of a constant force. And constant force means the acceleration is also going to be constant. So I can just say here, straight line, as acceleration is constant, as the force is, as it's under the action of a constant force. force is constant. Let's see what they wanted in the mark scheme. You know, what they wanted you to say in the mark scheme. Let's have a look if they were happy with that. Acceleration is constant. Yeah, that's it. That's all they wanted. Okay, in reality, the string is not live. State how this would affect the working in part B. Okay, if the string isn't light, if the string has mass, then all of a sudden the tension here is going to be different to the tension here. Yeah, the tension on A, basically, if the string has mass, and it depends where the center of mass is, but like as this passes over, the tension is going to vary, just because the weights, you know, the weight of the string is moving, if you like, from this side to this side, and so that changes the tension on both sides. So all you have to do is just say the tension in the string either side of the pulley will no longer be the same. Hope that makes sense, and that's the end of that one. So that's not too bad, this question. Hope that was useful. Keep up the good work.